At the end of this video lesson, you are expected to state theorems related to chords, arcs, central angles, and inscribed angles, and apply theorems related to chords, arcs, central angles, and inscribed angles in solving problems. We will be using two-column proof in proving these theorems. Also, you will use these theorems in solving problems related to it. Example, the first or left column has only mathematical statements. Then the second or right column has only reasons supporting the validity of those mathematical statements. Every logical ordered steps is numbered in both columns. So step 1 on the left is supported by step 1 on the right. You end when you have proved your concept. Theorems on chords, arcs, and central angles. Given, circle A with angle PAL is congruent to angle TAO. Now let us prove that arc PL is congruent to arc TO. Let us now make a two-column proof. So the first or the left column has the statements and the second or right column has only reasons. We will always start with the given. So ano ba yung given natin? Circle A with angle PAL is congruent to angle TAO. So we will prove that arc PL is congruent to arc TO. So yung number 1 natin, ang reason natin, obviously, ang reason natin ay given. So next, ipoprove natin na ang arc PL ay congruent sa arc TO. We know that arc PL is the intercepted arc of angle PAL. And angle PAL is a central angle. So therefore, the measure of angle PAL is equal to the measure of arc PL since angle PAL is a central angle. How about angle TAO? The intercepted arc of angle TAO is arc TO. So, the measure of angle TAO is equal to the measure of its intercepted arc, arc TO. So, our reason here is the degree measure of a minor arc is the measure of the central angle which intercepts the arc. So from the given, according to the given, angle PAL is congruent to angle TAO. So we can say that the measure of angle PAL is equal to the measure of angle TAO. Reason, definition of congruent angles. Now, if the measure of angle PAL is equal to the measure of angle TAO, tingnan natin yung number 2, the measure of its intercepted arc is equal to the measure of the central angle. By substitution, we can say that the measure of arc PL is congruent to the measure of arc TO. Ang reason natin ay substitution from statement number 2. We can now prove that arc PL is congruent to arc TO by definition of congruent arcs. So, we end when we have proved our concept. Our previous example explains theorem number 1, which states that two minor arcs are congruent if and only if their corresponding central angles are congruent. Okay, example. So let us use the previous example, which is circle A. In circle A, angle PAL is congruent to angle TAO, and the measure of arc PL is equals to 3x minus 15 degrees, and measure of arc TO equals 2x plus 5 degrees. Now, let us solve for x and find the measure of arc PL and arc TO. Unahin nating hanapin ang value ng x. Now, we know that arc PL is congruent to arc RTO because angle PAL is congruent to angle TAO and their corresponding intercepted arcs are arc PL and arc TO. Now, if the measure of arc PL is 3x minus 15 degrees, it is equal to the measure of arc TO, which is 2x plus 5 degrees. So let us equate the two measurements. Combine similar terms, we have 3x minus 2x is equals to 5 plus 15. 3x minus 2x is equals to x, and 5 plus 15 is equals to 20. Therefore, x is equals to 20. If x is equals to 20, from the measure of arc PL, which is 3x minus 15 degrees, let us substitute the value of x. Arc PL is equals to 3 times 20 minus 15 degrees. And 3 times 20 is 60 minus 15. Therefore, arc PL is equals to 45 degrees. How about arc TO? Let us substitute. Arc TO is equals to 2x plus 5 degrees. Substitute the value of x. We have arc TO is equals to 2 times 20 plus 5. Arc TO is equals to 40 plus 5, which is equals to 45. So notice that arc PL is equals to 45 and arc TO is equals to 45. Therefore, arc PL is congruent to arc TO. Theorem number 2. Theorem number 2 states that two minor arcs are congruent if and only if their corresponding chords are congruent. Given circle O and circle E. Illustration. From the given, circle O is congruent to circle E, and line segment AB is congruent to line segment CD. So, yung mark na blue doon, yun yung mark na yung dalawang segment ay congruent. Line segment AB is a chord of circle O, and line segment CD is a chord of circle E. According to the theorem, two minor arcs are congruent if and only if their corresponding chords are congruent. Since chord AB and chord CD are congruent, therefore, arc AB is congruent to arc CD. This explains theorem number 2. Theorem number 3. Theorem number 3 states that a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. So we have here circle D with diameter LU. Line segment LU is a diameter of circle D and perpendicular to the chord ME at O. Since the diameter is perpendicular to the chord ME at O, we can say that line segment OM is congruent to line segment OE. Also, arc LM is congruent to arc LE. So another arc, we have here arc UM is congruent to arc UE. Now, theorems 1, 2, and 3 are theorems about central angles, arcs, and chords. Now, we will deal some theorems involving inscribed angles and intercepted arcs. Theorems on inscribed angle. Theorem number 4. Theorem number 4 states that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. Example, a circle and an angle inscribed in a circle. So let us name this as angle BIN inscribed in circle O. Solve for the following. Given, if the measure of angle BON is equals to 70 degrees, what is the measure of angle BIN? Solution. Now, since angle BIN is inscribed in circle O, the measure of its intercepted arc is 1/2 the measure of angle BIN. But what is the measure of arc BN? So, dun sa given, the measure of angle BON is equals to 70 degrees. So, angle BON, the intercepted arc of angle BON is arc BN. And angle BON is a central angle. Therefore, the measure of angle BON is equal to its intercepted arc, arc BN. If angle BON equals 70 degrees, arc BN is also 70 degrees. So, we can now solve for the measurement of angle BIN. 1/2 of 70 degrees is 35 degrees. Therefore, the measure of angle BIN is 35 degrees. Next, let us solve letter B. If the measure of angle BON is equals to 3x plus 4 and the measure of angle BIN is equals to 32, find the value of x. We know that 1/2 the measure of arc BN is equals to the measure of angle BIN because the intercepted arc of angle BIN is arc BN and angle BIN is an inscribed angle. Now, how will you find the measure of arc BN? Dito muna tayo sa measure of angle BIN. So, dun sa given, the measure of angle BIN is equals to 32. To find the measure of arc BN, sa given, binigay ang measurement ng angle BON. And we know that angle BON is a central angle and its intercepted arc is arc BN. So, ang relationship nila, they are equal. So, binigay dito na ang measurement ng angle BON ay 3x plus 4. Dahil ang kanyang intercepted arc ay arc BN at equal ang measurement nila, ang measure ng arc BN is also 3x plus 4. So, 1/2 of 3x plus 4 is equals to 32. So, let us simplify. So, when you multiply a fraction, you multiply numerator times numerator and denominator times denominator. So, i-cross multiply natin yung denominator na 2 doon sa 32. The result is 3x plus 4 is equals to 64. Then, combine similar terms, we have 3x is equals to 64 minus 4. 3x is equals to 60. Then, divide both sides by 3. Therefore, the value of x is equals to 20. Theorem number 5. If an inscribed angle intercepts a semicircle, then it is a right angle. We have here circle O with the diameter NE. And angle NTE is an inscribed angle in circle O which intercepts a semicircle arc NSE. The endpoint of angle NTE is the diameter of circle O which is NE. Therefore, angle NTE is a right angle. Theorem 6. If two inscribed angles intercept the same arc, then the angles are congruent. Given a circle with angle PIO and angle PLO. Now, angle PIO and angle PLO intercepts the same arc which is arc PO. If angle PIO and angle PLO intercepts the same arc which is arc PO, therefore, the two angles are congruent. Theorem 7. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. I have here circle N and an inscribed quadrilateral. Let us name this as quadrilateral PQRS. quadrilateral PQRS is inscribed in a circle. According to Theorem number 7, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Suppose I have here angle QPS. The opposite angle of angle QPS is angle QRS. So, following theorem number 7, if we add the measure of the two opposite angles in an inscribed quadrilateral in a circle, it is equals to 180 degrees. So, another opposite angles. So, let's say angle PQR. The opposite angle of angle PQR is angle PSR. So, if we add the two opposite angles, it is equals to 180 degrees. Great! We're done. It is now your turn to answer the activities in your module. Follow carefully all the contents and instructions indicated in every page. Thanks for watching. Thanks for listening. This is Teacher Nati saying, let us thank God for all the blessings that He has given us.